Hey everyone, in this lesson we're going to keep exploring arrays. This time we'll be talking about multidimensional arrays. Now, it's not something you use every day, but there are definitely situations in programming where you need to group multiple one-dimensional arrays together. For example, think about making a game like Battleship or Tic-Tac-Toe. Both of these games have rectangular boards of different sizes, and each cell on the board holds a symbol. In Battleship, it might be a part of a ship, and in Tic-Tac-Toe, it's either an X or an O. So what if you wanted to recreate these games on a computer? Well, you can already imagine that each cell could be a separate char variable. Each row could be an array of these characters, but here's the problem. You don't just have one row, you have multiple rows, and they all form the board together. Sure, you could make each row its own separate array, but that quickly becomes messy. You'd end up writing a ton of repetitive code just to handle each row separately. There's a better way. You can create an array of arrays. That's what we call a multidimensional array. There are a couple of ways to define a multidimensional array. In the last lesson, we talked about one-dimensional arrays, arrays where each element has just one index. In a two-dimensional array, each element has two indexes. In a three-dimensional one, each element has three, and so on. Basically, any array with more than one dimension is considered multidimensional. In our case, for these two games, we only need two-dimensional arrays. Like I said, they're not used as often as regular arrays, and three-dimensional arrays are even more rare. Honestly, I don't think I ever actually used a 3D array in real life, let alone anything beyond that. One way to picture a 2D array is to think of it as a rectangle or a grid, while a 1D array is just a straight line. When it comes to the elements inside a 2D array, we usually interpret the first index as the row number and the second index as the column number. Now, keep in mind, even though a 2D array looks like a grid, in memory it's actually stored in a single line, just like a regular array. Another way to look at it is like this. A 2D array is an array of arrays. So if we have a 2D array that's 3 by 5, it means we've got 3 sub-arrays, and each of them holds 5 elements. A 3D array with dimensions 2 by 3 by 4 means we've got an array of 2 elements, where each element is a 2D array with 3 arrays inside, and each of those has 4 elements. Alright, so in this lesson I'll show you how to create these kinds of arrays, how to access individual elements, and how to work with them. Most of the examples will be with 2D arrays, but once you get the hang of that, you'll easily understand how to use 3D arrays or more if you ever need to. Let's get started. So, how do you create a multidimensional array? It's actually super simple. All you need to do is add another set of square brackets for each dimension you want. Here, I'll show you how to create 2D and 3D arrays, both with and without initialization. Let's start with 2D arrays. Since the final element in any array is still just a variable, you start by specifying the type of those variables. Then, just like with regular arrays or variables or constants, you give it a name. The naming rules are exactly the same. Next, you add the square brackets. Each pair of brackets represents one dimension. So if you use 2 pairs, like we're doing here, it's a 2-dimensional array. Now, let's look at a few examples. Array 1 is uninitialized. It's made up of 2 one-dimensional arrays, and each of those has 3 elements. Array 2 is initialized with zeros. It has 4 arrays inside, and each one has 5 elements. Array 3 is also initialized, but this time we're manually setting values for each element. Notice how many curly braces we're using. First, there's the outmost pair of braces that wraps around the whole array. Since array 3 is a 2D array with 2 rows, and we add 2 more pairs inside, 1 for each row. And inside each of those, we initialize a one-dimensional array. We talked about initializing 1D arrays in the previous lesson. If you mess up the number of values, like not matching the expected size, you'll get a compile time error. Also keep in mind, you don't have to use numbers directly for the sizes. You can use constants just like I did here with array 4. Now, let's quickly go over 3D arrays. A 3D array just needs 3 pairs of square brackets. You'll see I've labeled the sizes using depth, height and width, but that's just my way of naming them. Earlier, I also used rows and columns for 2D arrays. In reality, all of these are just array sizes, so call them whatever helps you understand the structure. Just remember, in memory, there's no actual plane or volume. It's still a flat chunk of memory. So, just like before, I created 4 3D arrays. One uninitialized, one filled with zeros, one manually filled, and one using constants for the sizes. Pay attention to how many curly braces we need now. There's one extra level. The outmost pair defines the 3D array. It contains 2 2D arrays, so we have 2 sets of braces inside. Each of those contains 3 1D arrays. So inside each of those, we have 3 more sets of braces. And finally, each of those 1D arrays holds 3 actual values. Accessing elements in a multidimensional array works almost exactly like accessing elements in a one-dimensional array. The only difference is, now you need to provide multiple indices instead of just one. You start with the array's name, then, in the first pair of square brackets, the index of the sub-array, then the index of the next level, and so on. The last index points to an actual value, the number that's stored in memory. So, if it's a 2D array, you use 2 pairs of square brackets and provide 2 indices. If it's 3D, you'll need 3 pairs, and so on. For example, let's say I create a 2D array that's 3 by 3. All the elements are initialized to 0. How many elements are in total? Just multiply the sizes. 3 times 3, that's 9 elements. So we have 9 numbers in total, 3 in each one-dimensional sub-array. We can access each of them, but to do that, we need to understand how indexing works. Let's say I want to print all the elements. I start with the name of the array, then I give the index of the sub-array. Important, this first index tells us which sub-array we're working with. In this example, we have 3 sub-arrays. The first one has index 0, the second 1, and the third 2. The second index tells us which element inside that sub-array we're accessing. And since each of them has 3 elements, the valid indices are 0, 1, and 2. So this way, I can print out each element in the whole 2D array. Now remember, when accessing elements, you can not only read their values, but also change them. Here I modified some values, then printed the array again. And as you can see, the changes show up. Now here's what not to do. Don't use negative indices. Technically the compiler won't complain, but at runtime your program will crash. Don't use decimal numbers as indices, that just doesn't make sense. Don't forget to write an index in every pair of brackets. Don't use commas to separate indices. Each index goes in its own pair of brackets. And finally, don't go out of bounds. If you try to access an index that doesn't exist, boom, runtime error. Multidimensional arrays can also be made constant. And the rules here are exactly the same as with one-dimensional arrays. You just write the word const at the beginning, then you must initialize all the elements right away. And then you can use them. Just don't forget, you can't change their values later on. Attentive viewers might have already noticed something. When we display array elements on the screen, we repeat the same action again and again. Only the indices change, which brings us to a key idea. When working with multidimensional arrays, we typically use loops for convenience, and the most popular loop is the good old for loop. Think back to how we loop through a one-dimensional array. We just use a single for loop. Inside it, we create a variable that represents the index of the element, and we increase it with each iteration until we go out of bounds. But when working with a two-dimensional array, we need 2 variables and 2 loops. Take a look at this code. I created a 2D array of size 3 by 5. It's empty for now, so I want to let the user fill it in, then display all the values. Let's walk through how the loops work. In a 2D array, the elements are actually one-dimensional arrays. Each of those arrays has its own index, so first we create a loop that goes through each sub-array. That is, the variable I will take the value 0 for the first sub-array, 1 for the second, and so on, until it reaches the number of sub-arrays. To make things easier to read, I named this count rows and I named the number of variables in each sub-array columns, so you can keep thinking of a 2D array as a table. Now, what do we do inside that outer loop? Since each sub-array contains a number of elements, we need to launch another loop inside the first one to go through each element of that sub-array. So you'll see another similar for loop with a few key differences. We create a variable j to represent the index inside the sub-array. That loop will run until j equals the number of elements in the sub-array, in our case 5. So we'll get 5 iterations. Inside the inner loop, we show the user a prompt and read the value into the specific variable. Notice how instead of using literals for the indices, I'm now using the variables I and j. Be careful not to mix them up. Once the user enters 5 numbers, we've filled up the first sub-array, and the inner loop ends. The variable j gets destroyed. Then the outer loop continues. I increases by 1. The inner loop starts again from scratch. J is recreated and set to 0. The user now enters 5 values into the second sub-array, because I is 1 now. And so on until the outer loop ends, when all values in the array are filled in. And that's pretty much how it works with 2D arrays when we want to go through every element from left to right. If you're working with 3-dimensional arrays or higher, just add more nested loops and don't forget to use more pairs of square brackets for indexing. I then use a very similar piece of code to print out all the values. But here's a question: how should we print them? With a 1-dimensional array, we could print values horizontally or vertically. Here, as with any array, it's up to you. In my example, I print the elements of each sub-array on the single line. Then I move to a new line for the next sub-array. That way, I get a neat table of numbers. Almost neat table. Let me run the program and show you how it works. You can also use nested range-based for loops with multi-dimensional arrays, although I've never seen anyone do that in my life. The thing is, when working with them, you need to understand one particular detail. Take a look at this code. It includes a construct you haven't learned yet, a reference to an array of 5 elements. We'll cover references in a separate lesson. For now, the main point is that these kinds of loops are possible to use, but it's still too early, and it's better not to use them yet. We'll come back to this code in the lesson about references. The last topic is the use of the escape sequence /t. I mentioned in the lesson about escape sequences that I would return to this one when we cover multidimensional arrays, and now the time has come. Let's go back to the program where the user fills the numbers in a 2-dimensional array. I'll run the program again and enter different numbers, each with a different number of digits. Now, look at the output. It's not exactly a neat table, but the program is doing exactly what I told it to, placing a regular space after each element. But what if, instead of a space, we output a horizontal tab? Let me run the program again and take a look at the output. Now, the output looks much nicer. That's because horizontal tabulation works in such a way that each number is allocated its own space, which measures 8 characters wide. If the number is 1 digit long, the remaining 7 characters are filled with spaces. If it's 3 digits, the remaining 5 are spaces. Thanks to this, the numbers are aligned in columns. However, of course, there are potential problems and inconveniences. If a number has 8 digits or more, then the formatting won't look nice anymore. Later on, when we get to the lesson of manipulators, I'll show you a much better way to format output on the screen. And that's the end of this lesson. Thanks so much for watching. If you enjoyed the video, you can support my work by giving it a like, leaving a comment, subscribing to the channel, becoming a channel member to get access to practice lessons, or donating via the link in the description. All of that helps the channel grow and keeps me motivated to make more lessons for you. Take care.